Sometimes it's really useful to be able to read and write files from the disk. This lets you gather in huge amounts of information, maybe data that you saved from the web, and it lets you save the numerical results of your sketches. When we talk about disk files, we typically imagine that your program is running on your computer and your hard drive is also running. This is a picture of a hard drive just like the one inside your computer. Your sketch can read a file from the hard drive and get at the information inside, and it can write a file to the hard drive and save information in it. In this discussion, when I talk about files, I mean only plain text files. There are lots of different kinds of text file formats out there. You've probably seen files that end in doc, or maybe .x, or RTF, or TXT. And these are just a few. There are lots of file formats. It turns out we don't want the top three. We only want the files that are stored in TXT. That's plain text format. Here's a little file inside of Microsoft Word. It's not plain text. There's all kinds of additional stuff in here. I'm changing fonts. I'm going from bold to italic. I'm changing the colors of the text. This is a lot more than just plain text. Every text editor, when you save, gives you the option of saving your file as plain text. To save this as plain text in Word, I choose Save As. I go to the Format drop-down menu, open it up, and choose Plain Text. And notice that it has a .txt on it. So I'll choose that and hit Save. If I close my file and reopen the text version I just saved, it looks like this. All the formatting information has been removed, and all we have are the letters and characters we typed on the keyboard. When we talk about files in this video, these are the kinds of files we're talking about. Plain text. So let's get into them. I'll start with reading files. Suppose that we have a plain text file on our disk called sa.txt, and it contains 4 lines of just normal text. The general idea is that we're going to read the lines in one at a time. When processing reads in a line, it treats it like a string, a capital S string, the data type that holds a bunch of letters. So let's give this particular string a name. I'll call it one line. Now that we have the line, we can do anything we want with it. When we read in files, very often we want to break apart a line into pieces. Here, I'd like to break apart the words. Well, I know that between each word there's a space. So this is a perfect job for the routine we saw when we talked about strings called split. It takes the name of a string and a character to use for splitting, and it gives us back a new array of strings. One string for each batch of characters that are separated by blanks. So the result of this little operation, if we were to draw it, is 5 strings in the array words, one for each word in one line. This is such a common kind of thing to do when you're reading in a file. Let's actually take a look at doing it. The key thing is that to read in a file, you only need to use one routine. It's called load strings, all one word with a capital S in the middle. It takes one argument, a string, so it's wrapped in quotes, that gives the file name of the file you want to open. And this is, again, always going to be a .txt file. What we get back is an array of strings, one for each line in the file. So if I want to open up a file called file.txt, here's what I would type. Load strings opens file.txt and gives us back an array of strings called lines. So let's go ahead and process them the way we just saw. I'll write a loop that steps through each of the strings in the array lines. And we know we have one string per line. So I'll type out a little message. This is line, and then we print out the line number, and then I will split the string into words. Now I'll just write a little loop that goes through each of the words and prints out that word. This is all it takes. Let's go ahead and run it. To start off, here's my plain text file sa.txt. It's just plain text, and by default, it comes out very small on the screen. Here's the program we just saw. It's exactly what we saw, except that I added void setup at the top and a curly brace at the bottom. So let's run it. If I scroll up to the top, we can see it says that this is line 0, and it prints out the 5 words on that line. Then it goes to line 1, and it prints out the 7 words, and so forth for each word on each line. That's all it takes to read a file. Often we want to read numbers out of a file, and so far we've only seen how to read in strings. So let's see how to read in numbers. You may remember this slide from our discussion of transformations. I made each of these animals by hand. I drew a little picture on graph paper and I wrote down all the points, and then I typed in all the points. And some of these animals just had dozens or hundreds of points. In previous examples, I actually saved this information in the processing file itself. What I'd like to do instead is to save it in a text file. That way my processing file gets much smaller, and I can even reuse this data somewhere else if someday I want to. So how can we read in this text file and turn it into an array of numbers? Here's the idea. I'll create an array of floating point numbers that I'll call animal xy. I'll store the points here the way I did before we discussed p-vectors. So it stores an x, then a y, then an x, then a y, and so on for every point. Like any program, we begin with a setup, and I create the graphics window I call smooth, and then I call a routine called read animal with the name of the file I want to open. That's the thing we're going to focus on, and I'll come back to that in a moment. Then I call a little routine to scale the data so it has a radius of 1. That makes it easier to draw. The draw routine doesn't do much. It clears the background, translates to the middle of the screen, figures out a scale factor so I can make the animal bigger or smaller, and then I call begin shape, and I run through all the vertices, x and then y, handing them to vertex. When I'm all done, I call end shape. So everything here we've seen before. The new thing is read animal. So let's take a closer look at that. I'll keep the declaration of animal xy up top so we can remember that's an array of floats, and we know that read animal takes one argument, the name of the file we want to open. Well, the first thing we do is what we just saw. We simply call load strings with the name of the file. We get back an array called lines, 1 for each line in the file. So let's look at this visually. Here's our starting file of the bear with all the xy's just in some big, huge text file. Once we've called load strings, we now have an array called lines, and it has one entry for each line in the file. So we can fill this array in. Line 0 goes into lines sub 0. Line 1 goes into line sub 1, and so forth. Notice that we read in the whole line, the numbers, the comma, the space, more numbers, and the comma at the end. I probably didn't need to have a comma at the end of the line, but that's how I saved the file when I was typing it. Okay, now that we have this big array of strings, we know how many points we have. We're going to have 1 point for each line. That is, we're going to have 2 floating point numbers. So now I can make the animal xy array. I just make a new array whose length is twice the number of lines. So, okay, we can even draw this array, and I'll draw that down here at the right, and it's huge, and I'm just drawing the first 8 entries. I'm going to want to start putting numbers into animal xy, so I'm going to create a variable called animal index. That just tells me which entry in the array animal xy I want to write into next. Right now I'm setting that to 0, so in the animal xy array, let's draw a big arrow pointing at index 0. Now let's fill in the array. So I'll write a loop that goes through all of the lines. First thing I'll do is I'll take line sub I and split it into words. So words is now a new array of strings, and it's going to have one entry for each word in the first line. Notice that I'm splitting on the comma. So processing starts at the beginning of line sub 0, and it reads off the 1.000, and then it hits the comma and says, okay, you get everything up until the comma. That goes into the first entry in words. Then it starts again after the comma, and it sees space minus 0.426, and then it hits a comma and says, okay, you get everything up until the comma, including the space at the beginning. Then it picks up again after that second comma and it says, oh, there's nothing there. So it creates a third entry in the words array, but it's an empty string. Well, that's fine. We only care about the first two. So now we want to take the first entry in words, that is word sub 0, and turn it into a floating point number. We know how to do that. We just hand it to float. Now we have a number, and we stick that into animal XY at the position pointed to by the arrow. So the 1.000 slides right on in. Animal index has a plus plus at the end, so after this line has executed, animal index is now 1. Now we do another line, where we just move the next number into word sub 1. So float will take space minus 0.426 and turn it into the actual floating point number negative 0.426. Sticks it into animal index sub 1. We move down to the next entry, and around the loop we go, taking each line in turn, breaking it into words, and then copying the words into the array. The result is a nice big array of floating point numbers XY, 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 using up all the entries in the file. Here's the program running when I have the bare data in the file called object.xy. If I change the contents of that file, really just by renaming some other file object.xy, then I get a different animal. And of course, these don't have to be animals. These can be outlines of states or countries, or rainfall in a given area over time, or temperature. Any numbers that you want to store in a file for any reason, you can read with this technique. So that's how we read a file. In part 2, we'll see how to write a file.